Okay.
Okay, gentlemen, this morning we're going to talk about AIRC 1020B, and that's going to be condensers and evaporators. The thing about condensers and evaporators is they're major parts of the refrigeration system. And they perform a particular job or task in the refrigeration system. You all remember the basic definition of mechanical refrigeration? What's the definition of mechanical refrigeration? You mechanically remove heat from one place where it's not wanted and you reject it in another place where it doesn't matter. Well, the condenser actually rejects heat. It's the component in the refrigeration system that rejects the heat. Typically, the condensing unit is outside, and that's the component that you would have outside. And you know, when you walk by the condenser, you feel the air coming off the top of the condenser, and it feels warmer than the ambient air. Well, that's the heat being rejected that was absorbed in the conditioned space. Now, there's several different types of condensers, and of course, the text touches on several types of condensers. And again, remember, keep in mind that the condenser has a solitary purpose, and that is to reject heat. So, you know, you want to keep that in mind. You've got the air-cooled condensers, water-cooled condensers, and then you've got the evaporative condenser, which is a combination of the two. The air-cooled condenser is pretty common. This is an example of an air-cooled condenser. I don't know if we can get a good look at this, but this is a small condenser that's a part of this condensing unit. And that's something else that you see a lot of. When you think condenser, you typically think about a condensing unit. When you purchase the condenser, usually you don't purchase just a coil. You usually purchase a condensing unit. That's how they're typically manufactured. Now, in some instances where you install a large commercial system, you may have just a condenser coil, and then you add the compressor and the other components. But typically, the condensing unit comes with the compressor, the condenser, coil, and the condenser fan. That's a typical condensing unit. On an air conditioning system split system, you've got your condensing unit that sits on the outside, you've got your compressor, your condenser coil, and your condenser fan. That's a typical condensing unit, or a typical air coil. And you see that a lot in residential systems. From time to time, you might see a water-cooled condenser. This is an example of a water-cooled condenser that you might have on a water source heat pump. You've got the water that enters these tubes, and you've got refrigerant that enters the refrigerant tubes, and they sort of circulate inside each other. I don't know if you can see where that's cut apart, and you see the refrigerant lines encapsulated in the water tube. And so this is what you have if you have a water source heat pump. Water source heat pumps are pretty popular. Typically, you have an air coil and a water coil. And in the cooling mode, the air coil is the evaporator, the condenser, the water coil is your condenser. If the unit is in the heating mode, the air coil becomes your condenser and the water coil becomes your evaporator. But keep in mind, the condenser does what? Rejects heat, and the evaporator absorbs heat. So when you understand what the condenser does, you can recognize, you know, the part that it plays in the system, and you know what it's supposed to do. Now, what happens inside the condenser? You've got the hot gas coming out of the compressor discharge line, entering the inlet of the condenser, and immediately that refrigerant begins to reject heat. As it begins to reject heat, it changes from a vapor to a liquid. And that's where your latent heat stage occurs. As long as that refrigerant is changing state from a vapor to a liquid, you've got latent heat rejection that's occurring. And that's how the heat is rejected. Now, you've got to have a medium of exchange, whether it be air or water, that is of a cooler temperature than the hot refrigerant gas. If the hot refrigerant gas or vapor is about the same temperature as your medium of exchange, no temperature transfer is going to occur. And it all goes back to the basic fundamentals of HVACR. Heat always travels toward a cooler temperature. Let's say, for example, that it's 95 degrees outside, and you've got your air-cooled condenser sitting outside. You got 95-degree air blowing across those coils. Well, that 95-degree temperature air seems pretty warm, right? But the fact is, the temperature of the refrigerant inside that condenser is probably somewhere around 120 or 125 degrees. So you got 95-degree air blowing across that 120, 125-degree coil. You're going to have a natural heat transfer that takes place. So the heat from the refrigerant vapor in the condenser is going to be given up to the cooler air that's blowing across the condenser. Same thing with the water-cooled condenser. If you've got let's say that you've got 120-degree refrigerant inside that water tube, and you're going to have 90-degree water, 85-degree water entering that coil. You've got a temperature differential, and so the heat inside the refrigerant vapor is going to be given up to the cooler water that's circulating through that coil. Typically on your air-cooled condensers, your water temperature, your entering water and leaving water is almost always 10 degrees. If you've got 80-degree entering water, you're going to have 90-degree leaving water. That's pretty much a constant when it comes to water-cooled condensers. Is there any questions so far? Anybody have any questions so far? What kind of problems occur with condensers? Most of the time we have a restriction or dirt gets embedded into the coils, and the coils get dirty. They have to be cleaned. If you got a condenser fan, you have problems with your fan. That's going to cause your head pressure to rise. And speaking of head pressure, that's one of the symptoms of condenser problems. Your head pressure is going to be higher than normal, because it's not getting rid of the heat inside the refrigerant vapor like it should. And so that'll cause your pressures to go up. On water-cooled condenser, if you lose your water pump or your condenser coil gets scale built up, and then that scale causes an insulation factor inside the water tubes, it's not going to reject the heat as well as it should. A common service procedure in residential HVAC and light commercial and even commercial HVAC is to clean that condenser coil. Now, that's really important. That's a common service procedure. It actually needs to be done at least once a year, depending on the conditions. If it's really dusty or dirty conditions, it may need to be cleaned more than once a year. But cleaning that outside condenser coil to keep that coil clean is really important. Any questions? So what does a condenser do?
Rejects heat.
Rejects heat out of the refrigerant vapor. That's correct. Now, let's keep in mind that your subcooling occurs inside your condenser. And remember what we said earlier, understanding superheat and understanding subcooling, very important in the refrigeration process or the refrigeration cycle. It's imperative that you understand the term subcooling, what it means, why it's important. Subcooling begins when all of your refrigerant changes to 100% vapor, and we refer to that as saturated vapor. Saturated liquid if we're talking about condenser. What does the term saturated liquid mean? That's the point in the condenser where no more vapor to condense. It's 100% liquid. The temperature of that liquid corresponds to your pressure in the condenser, and that's also known as your condensing temperature. So that's very important. What's the term that we called it? Saturated liquid. That's when the liquid in the condenser is 100% liquid and it corresponds to your condensing temperature. Okay, the condensing temperature corresponds to your pressure or your high side pressure. We're going to call it head pressure. You can call it head pressure, discharge pressure. Those terms are real common. Discharge pressure, head pressure, condensing pressure. That pressure, when it corresponds to your condensing temperature and it's 100% liquid in the condenser, that's when your refrigerant, that's the point where your subcooling begins. Let's say you've got a condensing temperature of 120 degrees.